Okay, so today's date is January 6th, 2015, and the topic we're going to discuss is distributive property. We're going to be using the distributive property to solve expressions and equations. The essential question that you should be able to answer at the end of the video is how can you use the distributive property to solve expressions and equations? So when we're talking about the distributive property, imagine a truck that's going to deliver fruit to each one of these major grocery stores. So here's our truck, and they have their product, and they're going to go to H-E-B and distribute fruit there, and they're going to go to Walmart and distribute fruit there, and then they're going to go to Target and distribute fruit there. So the distributive property is very similar to this process of a delivery truck taking its product to each individual store. Each individual store gets the same product. So now let's apply that to math. We're going to be using the distributive property, and if we have a problem like 5 times 27, you're actually breaking apart 27 into two different addends. And what that looks like is 20 plus 7. There's 20 tens and 7 ones. So now instead of having 5 times 27, you may see a problem that says 5 times 20 plus 7, and the 20 plus 7 is in parentheses. Since there's no operation on the outside here, it means multiplication. Now we're going to use the distributive property to solve this problem. We're going to multiply each addend by the number on the outside of the parentheses. So that means we're going to take 5 and we're going to multiply it to 20, 5 times 20, and then we're going to take 5 and multiply it to 7, 5 times 7. Since the operation inside the parentheses is addition, that means we're going to add our products. So once we actually multiply 5 times 20, which is 100, we're going to add it to 5 times 7, which is 35. So then we'll have our answer, 135. So 5 times 27 equals 135. You may be asking, well, why do we need to go through that entire process when we can just simply multiply 5 times 27? I'll explain the why in just a little bit and why it's important to know the distributive property. First, I want to make sure you understand what I mean by taking the number on the outside and distributing it to the numbers on the inside of the parentheses. So we're going to practice that. Another way to remember how the distributive property works is think about Oprah. If we have this crazy problem here at the top, 3 times 1 2/10 minus 5 plus 1/2. That seems like a lot of work, but the process is still the same. One thing Oprah's known for is giving gifts out to everybody in the audience. So basically the distributive property is the exact same way. So here we have Oprah, and she says, you get a 3, you get a 3, and you get a 3. Everybody inside the parentheses is multiplied to 3. So then it would look like this once we distribute the 3 to each number on the inside of the parentheses. 3 times 1 2/10 minus 3 times 2, I'm sorry, that should be 5, plus 3 times 1/2. So each number on the inside of the parentheses receives a 3. That is exactly how the distributive property works. So let's do some guided practice questions. Here we have 8 times 10 minus 7. So if I were to distribute the 8, it's going to be 8 times 10 minus 8 times what number? We have to distribute the 8 to the 7 as well. So it would be 8 times 7. 5 times 45 plus 5. Again, distribute the 5 to each number in the parentheses. So it's 5 times 45 plus 5 times 5. Here's another example. 7 times 31 plus 19, which equals 7 times 31 plus 7 times 19. Now that we've kind of gotten the hang of distributing the number on the outside of the parentheses to what's on the inside of the parentheses. Now let's try to solve the problems. So here we're going to distribute and solve the problems. 5 times 22 minus 5 equals 5 times 22 minus 5 times 5 when you distribute it. So you end up with 110 minus 25, which equals 85. Our next problem, 3 times 58 minus 8, which equals, once you distribute the 3 times 58 minus 3 times 8, which equals 174 minus 24, but our final answer is 150. Here's our last guided question. Again, distribute what's on the outside of the parentheses to everything on the inside of the parentheses. So then we would do 2 times 41, and since the operation on the inside is addition, we're going to add, and then we're going to distribute the 5 and the 2, so then it's 2 times 5. Once we multiply 2 times 41, we get 82, and we multiply 2 times 5, and we get 10. We're going to add those products together, and our answer will be 92. So now what I want you to do is some independent practice problems, which will show up on the side of the video, and I would like for you to take your time and answer those questions. Please make sure that you work every single step out in your Cornell notes so that I can see your thought process, and then answer the multiple choice questions on the side. Now we're going to talk about algebraic expressions and equations. So earlier, I'm sure you were wondering, why can I just multiply the numbers together? Well, the reason why you were having to use the distributive property is when we're dealing more with the algebraic side and not so much the numerical side. So earlier, we talked about a problem that looks similar to this. You have all numbers, you distribute the 2 to the 5 and the 2 to the 4, you multiply and you add the products together, and you get your answer 18. Very simple. Here's another way to look at the numerical side of it. You're basically saying you're going to multiply 2 plus 4 2 times. So you can even write, I'm sorry, I keep replacing the 5 with the 2. What you're going to do is you're going to multiply 5 plus 4 2 times. So here it says 5 plus 4 plus 5 plus 4. Again, same concept, 9 plus 9, and you still get the same answer of 18. But both of these ways are numerical. What happens when we receive a problem like this? 2 times x plus 4. Can you just simply add x plus 4? No, it does not equal 4x. That is not how we add when we have a variable. So what we're going to have to do is distribute the 2 to what's on the inside of the parentheses. So we have 2 times x plus, because that's our operation inside the parentheses, 2 times 4. And when we multiply that out, we have 2 times x, which equals 2x, plus 2 times 4, which equals 8. Now let's say this is an expression right now since we do not have an equal sign. But if I were to make an equation and actually set this expression equal to 18, we'll be able to solve for the variable. So here we have 2x plus 8 equals 18. Again, I want to isolate my variable, but right now it's being added to 8, so I'll subtract 8 from both sides, and I'm left with 2x equals 10. And since my variable is being multiplied to 2, I'm going to do the inverse operation, which is division. I'll divide by 2, and 2 divided by 2 is 1, and 1 plus x is x. And then 10 divided by 2 is 5. So that leaves me with x equals 5. And if we put our answer 5 and substitute it back in our original problem for x, we're going to end up with the same answer of 18. So that is correct. So this is the main reason why the distributive property is so important. Now let's work on some guided practice questions together. Again, the first half, I just want you to get used to distributing that number on the outside to what's happening on the inside. So we have 3 times 5 minus y, which is the same as distributing the 3 to the 5, 3 times 5, minus, because that's what's on the inside of our parentheses, 3 times y. Again, 10 times m plus 2. Once it's distributed, it's 10 times m plus 10 times 2. Then you have 6 times 3 plus a. Again, distribute the 6 to what's on the inside of the parentheses. 6 times 3 plus 6 times a. Now that we've distributed, let's solve for the variables. So that means we have to create equations. So let's do 3 times 5 minus y equals 0. Again, distribute the 3 to what's on the inside of the parentheses. 3 times 5 minus 3 times y equals 0. Solve for the multiplication. 3 times 5 is 15 minus 3 times y is 3y equals 0. And since we have a positive 15 on this side, we want to, since we have a negative 3y, I don't want my variable to be negative. So I'm going to move this to the other side of my equal sign so that I can make it positive. How am I going to move it? Well, it's being subtracted, so I'm going to do the inverse operation of subtraction, which is addition. So if I add 3y to our negative 3y, I'll end up with 0. But if I add on this side, I must add to the other. So I'm left with 15 equals 3y. Since the 3y is being multiplied, I'm going to divide by 3 and both sides by 3. So my final answer is 5 equals y. Again, if I put that back into our original equation, 5 minus 5 is 0, and 3 times 0 will equal 0. So that means it checks out. Here we have 10 times m plus 2 equals 40. Again, distribute the 10, multiply, and since we can't add our products together, we're having to isolate our variable. I want to get rid of the positive 20, so I'm going to subtract both sides by 20, and I'm left with 10m equals 20. Since my variable is being multiplied to 10, I'm going to do the inverse operation of multiplication, which is division, and I'm going to divide both sides by 10, and I'm left with m equals 2. If I were to substitute 2 for my variable in my equation, 2 plus 2 is 4, and 10 times 4 is 40. So it will check out. Our last guided question is 6 times 3 plus a equals 54. Again, distribute the 6. Multiply your products and isolate your variable. So first we're going to subtract both sides by 18, and we're left with 6a equals 36. And since our variable is being multiplied to 6, we're going to divide by 6, and we're left with a equals 6. Again, put that answer back into our problem. 3 plus 6 is 9, and 9 times 6 is 54, so it checks out. Again, you have some independent practice questions on the side. Please make sure you work out every step in your Cornell notes, so when we check it, we'll be able to help in case you have any questions. Please make sure you write those in the question section of your Cornell notes.